Hello, my name is Gabe Lind, and with the help of Andrew LaRock and Andrew Carr, I'd like to talk a little bit about reactive azeotropes and their role in thermodynamics. Many binary mixtures have a vapor and liquid phase. These phases have their own compositions, and these compositions can be related using Raoult's law, equation 8.3. In addition to these compositions, it uses pressure of the system and saturation pressure of the species being discussed to determine the values for the liquid and vapor phase compositions. Raoult's law is based off assumptions such as the liquid and vapor phases behaving ideally, and it predicts this straight line on the graph seen below. However, in the real world, you typically don't see ideal conditions being satisfied, so you have deviations resulting in the lines XA and YA. These can be calculated using a more generalized equation, 8.13. However, these deviations can become so great, such as in this graph, at the concentrations of XA and YA about 0.8, called an azeotrope. It is a temperature and pressure at which the composition of the liquid and vapor phase is exactly the same. We were able to find an article that was doing research on azeotropes, specifically azeotropes in systems with chemical reactions. Given it's a much more complex system, they redefined variables XA, XB, and XC. In this mixture of acetic acid, isopropyl acetate, isopropanol, and water, they were able to reach azeotropic conditions with the compositions of XA, XB, and XC as seen at the bottom of the slide, at a temperature of 78.99 degrees Celsius. What is so special about this specific azeotrope, however, is that it exists at chemical and phase equilibrium. Prior to this research, it has been proven on paper that it was possible to have an azeotrope at chemical and phase equilibrium. However, it had never been determined experimentally. However, on the graph seen above, you can see that experimentally they found an azeotrope at this point, with other relations existing as you deviate. However, the azeotropic conditions at this point are unique to this specific article and show something that we previously had never observed. This just shows how much the field of thermodynamics, specifically with azeotropes, is still advancing to this very day.